Welcome to Entry-Level Exploits. The concept of this series is simple. Find a bug, submit a valid report, and get your first bounty. And because we're partnering again with Bugcrowd, I am cheating a little bit because I asked them to just tell me what the most common first vulnerabilities are for their hackers. And now I'm going to break them down and show you how to find them too. We'll cover a kind of TLDR of the vulnerability, what you need to know, give you a step-by-step methodology to find and exploit the vulnerability, and do a hands-on practical demonstration on a CTF and a real website. So you can replicate my methodology, use it on your own targets, and build up your own hacking methodology over time. My goal here is simple, to get you to unsubscribe from my channel and never watch my content again. Welcome to this week's video on insecure direct object references, or IDORs. Okay, so what actually is an IDOR? At its heart, it's a type of broken access control, and it's probably one of the easiest vulnerabilities to both understand and to actually find as well. IDORs have lots of different names, so don't worry if you'll see IDORs pop up under lots of different names, but don't worry. The OWASP API Security Top 10 calls it a BOLA, or Broken Object Level Authorization. Some people just call it Broken Access Control. It's all the same fundamental flaw. Imagine you're logged into your university's student portal. You click on View My Grades, and the web browser sends a request to the server that looks something like this. Get/student/grades with the parameter of ID equals to 123. The server sees your ID as 123 and fetches the grades to show them to you. That's all working as intended. But what happens if you're not? What happens when you change it from 123 to some other number, 456? That's an IDOR. An IDOR happens when you, the student with the ID of 123, manually changes the request to replace the 123 part with a different ID like 456. Now, ideally, the server should stop and go, hey, hold on a second, you're not logged into the right account. Are you actually allowed to see other people's grades? Maybe it does some more logic, maybe it looks if you're an admin or you have the right role, but if it just sends you the data, that's an IDOR. The server correctly identified who you are, as in you've logged in successfully, it knows that you're logged in, but it doesn't actually check what you're allowed to see, whether or not that's because of permissions and roles, or whether or not that's because you're logged into the wrong account. Although most IDORs are P3s or P2s, they can be P1s or crits in some cases. So particularly where we're seeing large amounts of private data being leaked, DMs, personal details, financial records. If you're able to exploit it to a full account takeover or privilege escalation, if you're looking at an IDOR in a password reset, email change function, you may be able to use a very simple IDOR to take over any user's account. And data tampering. A lot of that and data tampering, it's not just about reading data, you could modify and delete other users' information, and this is particularly concerning depending on the industry. For example, finances, you can imagine you could make a transaction on somebody else's account, that would be considered P1 for a lot of customers. Okay, so what should you keep an eye out if you're going to hunt IDORs as a first bug? First thing is complex permission hierarchies, particularly when you've got multiple roles, the idea of tenants, permission levels, any kind of sharing. The less you understand the permission hierarchy, the better it is to hunt for IDORs in it. Any kind of large attack surface, IDORs are particularly broad vulnerabilities. You need a lot of different endpoints, a lot of different functions, a lot of different IDs. You need an application that is going to have that kind of broad scope. If you have a smaller scope application, you're just going to get in a situation where you can test it in 5 minutes and somebody else has already done that. Now, speaking of IDs, always test for IDORs when you see any kind of ID, even if they are UUIDs or another type of unpredictable ID like an alphanumeric ID. You really want to be exploring applications wherever you see an ID. But why am I constantly recommending IDORs to beginners? And with that, there's a lot of bug bounty meta, I will say, at play here. So IDORs are not technical bugs. They're more about the logic of an application than your actual technical skills or something like a POC. So if you compare it to other vulnerabilities like remote code execution type vulnerabilities, You don't need as much technical knowledge. You don't need to know as much about how the application works. Instead, you're looking at the logic of the application, how it processes things. And with that, they are really tedious to test. And top hackers just don't want to spend the time testing them. For top hackers, they don't want to spend the time testing them for a P3. You need to fully explore a functionality, an application. You're going to have to make multiple accounts and switch logins. And it's not easy to automate it, for example. And so you have the aspect of there being a little bit less competition from the top hackers for IDORs. So let's quickly chat about recon. There's no specific recon you need to do for IDORs. You should make sure you explore as much of an application as you can though. You may need to do something like API recon. I actually have a full video on that if you want to go through that in depth. But for the most part, you're trying to find obscure features that no one else has tested yet, either because they're new features, as in the program has only just launched them, the code has only just been committed, or it's in an obscure part of the application. It's not part of the main app. Maybe it's in a setting menu. Maybe it's something that only applies for specific customers of theirs. Okay, enough about the theory. Let's get into the practicals. So you can see I have my Burp set up here. So I'm using Burp Suite Community Edition. You don't need to pay for Burp to be able to find IDORs, just the free version. Though I do recommend the extension Logger Plus for searching, especially when you're dealing with a lot of IDs. Helps you find where that ID was exposed. I've got it all set up. I'm using Firefox. So my recommendation when it comes to doing any kind of multiple account testing like IDORs is to use something like PwnFox or Firefox multi-account containers to be able to log into multiple accounts at once. Now, I really like PwnFox because it then colorizes it inside Burp and it makes it a little bit easy to tell the difference between your two accounts, but I'll just show you. So you're going to start out by just going new container tab, and you can see here, this has now opened up PwnFox Blue. So if I go into the juice shop, you don't have to use juice shop, the methodology is the same. And you can see that my entire Burp history has now turned blue because it's getting everything from this blue tab. If I go to PwnFox and I click on the red tab, now all of the connections are in red. Now we create our two accounts. So I'm going to create two accounts, my victim and my attacker. So I'm going to create my victim account first. And just so I can tell the difference, I'm going to use victim at victim.com. Now, if you're doing a lot of testing with different accounts, I really recommend getting a password manager like 1Password, creating like a vault that's separate for your hacking credentials just to make it easier. Obviously, if you're testing on like a Bugcrowd program, you can use your Bugcrowd Ninja account and you can put up some email automation rules just to make that a little bit easier. Okay, so I've got my two accounts. What do I do now? I'm going to start out on my victim account and just start exploring the web page. I'm just trying to understand how it works, where those IDs are being used, and potentially where I might be able to spot vulnerabilities. I'll do things like add things to my basket. I'll do things like view my basket, go into my account details, order history. I'll check out. Here, what I'm trying to do is have a better understanding of how the application works. Whenever you're looking for a bug, you really want to make sure you understand how this application is supposed to be used first and then jump to the hacking. So as I do this, I'm going to start seeing various IDs in my results. I'm looking for where I can see any kind of numeric IDs, UUIDs, or just alphanumeric IDs in general. So I'll check both the request and the response to see where those IDs are being visible. And I can see here there is a ID for REST, so it's a RESTful API, basket 6. And then I'm going to go on to my attacker here and I'm going to do the same thing just so I can compare them. So now I can see I've got REST basket 6 and REST basket 7. Any other authentication that this application has in place is in this request somewhere. In this case, it's probably the bearer token. It might also be the cookie. Really, I want to minimize what edits I make to this request because I don't want to accidentally affect the authentication. And so the ways I can do this, I'm going to just send this to repeater. I can go into here, go to repeater, and change this 7 to 6. I'll wait for the response, and we can see we've got a 200 OK, and we've been able to see somebody else's basket. Yes, it's really just that easy. IDORs are very simple vulnerabilities. Now, the problem is, especially as you look at more complex applications, it may not be quite that simple to recognize where that ID is. If I refresh this page and get that request back up, this is the victim's account. Now, I'm going to send this to repeater and use what I've been calling the cookie trick. And I'm just going to copy where I think the authentication token is, so in this case, the bearer token, and replace it with my attacker account. I'm essentially doing the same thing as logging out and logging back in. Now, I think that there is another JWT down here where it says token, so I'm going to copy that. So because I've only edited this token here and the bearer token up here, I haven't impacted any other parts of this request that might be where the ID is being set. Now, obviously, we know the ID is here, but this is for applications where you may not know where that ID is. So the first thing I've gone ahead and done is register 2 accounts, my attacker, this account, and my victim, this account. First thing I'm going to do is I'm going to log in as the victim and do something that creates a private object. So in this case, I'm going to start by just exploring the application, adding things to my basket, and I can see as I add things to my basket, I'm seeing an API request to basket and then an ID. Great, I've got an ID, I've got a good place to start. So I'm going to log out, and then I'm going to log in as the attacker. We can see an ID in there. So we can see that this ID is numeric, or at least it seems to be numeric. So we can guess our victim registered maybe right before us. So a reasonable guess is their basket ID is just going to be 1 less. So we change the ID, we send it to repeater. Yep, we can see another user's basket. And it is that easy, at least to exploit a CTF website anyway. We're able to look at the context of the victim's private shopping basket. Is this the most impactful vulnerability? No, but we have affected the access control model of the web application, and so in many cases it would be considered a valid vulnerability. That is it. That is fundamentally what happens. Instead of having to log out, log back in, know all the IDs, remember all the IDs for all the accounts, instead you're going to you're going to log into both accounts, you're going to go into burp, you're going to repeat the request, and you're going to identify the logon. You're going to identify the cookie, the token, whatever's controlling the logon. It's usually just in the cookies. Once you've done that, you're going to take the cookie from the other session, your attacker's session, copy it, paste it, and replace it. Meaning you've essentially done that whole step of log out of one account, log into another account, know the IDs very easily. And again, if you're affecting the attacker's account with the attacker's cookie, that's not a vulnerability. You have to be affecting the victim with the attacker's cookie. That is your IDOR. So before we're in a rush to report anything, we need to sanity check ourselves. We need to do a little bit of due diligence just to make sure it's a genuine vulnerability and we're not affecting our reputation. As you're testing, you're going to see numeric IDs like 123, 124, 125. They're great because you can easily guess the next one, right? Add 1 each time. Now, sometimes you'll see random looking IDs. These could be UUIDs where there are dashes between everything. They could be just alphanumeric IDs that are just really long, or they could be hashes. Now a lot of people will assume that where it's a UUID, because you can't guess the next one, it's not a valid vulnerability. That's not true. The vulnerability is actually the same. You just can't guess the UUID, but you don't have to. All you need to do is find where that UUID is being leaked. The 2-account method works great for this because we find the UUID and just swap it in. But for a real target, you need to make sure you understand where those IDs are leaked. That could be a different API request. That could be a different functionality. But often some customers will accept it with just the broken access control, regardless of being able to generate a UUID, because a sufficiently motivated attacker may just be able to guess UUIDs and may take the time to guess them. A common pitfall I often see is people confusing private data with public data. If you change a user ID and you can see someone else's public profile, their username, their profile picture, is that information already public? Is that the same information that I can see just by being logged out? If it's just public data, often it's not a vulnerability, it's a feature. You need to make sure you're looking for sensitive, non-public data. We also need to check the cross-account interactions. We should be able to do something to another user's resource, so we don't need the victim's cookie or anything like that. We should just be able to use our attacker's cookie. Another thing is to just check response codes. If you change the ID and you get an access denied message, a 403 message, a 401 message, if the data didn't work, if the data didn't change, the vulnerability doesn't work. It's really simple. Okay, a CTF is one thing, but let's look at this on an actual target. And let's start by actually choosing a target. IDORs are the most common in complex applications that have to manage a lot of different data objects for a lot of different users. Think e-commerce sites, social media platforms, healthcare portals, SaaS project management tools, anything where you need an account and private data, or where you have complex permission hierarchies and scopes. All of that signals, hey, you should be looking for IDORs. On Bugcrowd, you specifically want programs with wide scope, like this gives you the most functionality to test. Read the program brief. If they mention user accounts, different permission levels, organizations, projects, it's a huge sign that access control is a critical part of their application. The first thing I look for is really large scope programs. This isn't necessarily that smaller scope programs can't have IDORs. I found IDORs in smaller scope programs all the time, but having something that kind of takes a little while to get into is going for that bug bounty meta of what aren't people looking. So I recommend larger scope projects. I also recommend looking for targets that have APIs. Now, these are incredibly common vulnerabilities in APIs. So looking for APIs or mobile applications, you're going to see a lot of IDs in there because that's how APIs are supposed to work. You can also look for other web applications as well, but I do recommend focusing on APIs. I've pulled out some that I think are quite good to start with. Atlassian, I pulled out Atlassian here just because the scope is so large. It includes all of Bitbucket, Confluence, Jira. It basically is anything star.atlassian.com. They've got other software like Rovo, they've got the Atlassian Marketplace, they've got Loom. They have a lot of different applications, and you can even see on some of these that... Now, it's important to note that for Atlassian, they do have this here. They're not interested in vulnerabilities surrounding enumeration and information gathering. They're looking for vulnerabilities that have a direct impact to some of their platforms. So that's always worth considering. If when you're looking for IDORs, it's not enough to be able to find information. I need to be able to edit it in some way. Most of it is in scope, and there's gonna be a lot of IDs in their development software. It's a software company. Same for Dropbox as well. It's software, they've got an API. There isn't quite as much scope as something like Atlassian, but Atlassian might be super overwhelming anyway. So better to start somewhere a little bit smaller. And again, you've not just got your web apps, you've also got your mobile apps as well. From a meta perspective, that's really helpful because if you're looking at mobile apps, there's less competition there, particularly for bug bounty hunting. Same here from T-Mobile as well. They've got an entire API in scope. They've got Sprint. They've got T-Mobile in scope. They've got supplemental assets as well. Again, it's just a really nice large scope target. We've got some apps in there too. And you can see while there is stuff that's out of scope, honestly, it's quite small. So again, we're going to be thinking, okay, how can we abuse this? And again, looking at e-commerce stuff like BigCommerce, you've got an entire application here. It's got an iOS and Android app. Again, not quite as large scope. They've got some other things here that are probably third-party applications that are not going to be relevant. but nice scope. So I pulled out Asana here as well, same kind of idea as for Atlassian. You've got this idea of organizations, you've got this like interest in remote codecs, you've got the interest in PII. Okay, that's always a good sign to see. I've also pulled out Hut Group and iFood, same kind of thing, right? They are e-commerce applications. E-commerce is always worth checking out for IDORs because you have orders, you have baskets, you have addresses, you have credit cards. All of that can be really sensitive information and all be IDORs, really. Okay, so let's actually look at this on a real website. You're going to find IDs in lots of different places as you are hunting. They could be in the URL path. That tends to be the most common, particularly with API vulnerabilities. They might be in the query parameters. For example, they have a specific order ID. They might be in request bodies. Again, very common for APIs. But also you need to be really careful because they might be in custom headers or in other places that you don't, or other places that maybe you haven't. Sometimes, especially with multi-tenant apps, you might find things like custom headers being used. So it's always worth keeping an eye out for that. Okay, here is your TLDR summary for IDORs. What is it? It allows you to access or change a resource you don't own if you know its identifier. It can affect any CRUD action, which is create, read, update, delete, depending on the access control model of whatever application you're testing. Where are you going to find it? Any kind of broad scope programs are really great. If you're seeing IDs, whether they be numeric IDs, auto-incrementing IDs, alphanumeric IDs, or UUIDs, they're going to have access control issues. It's very common in APIs, particularly because they have such a large attack surface. Industry-wise, you see it a lot in e-commerce, social media, and SaaS applications, but honestly, anything with complex permissions can be vulnerable to IDORs. Why is it a bug? It breaks the permission model of an application. You can view sensitive data, make unauthorized unauthorized changes. Often these vulnerabilities can be chained into really impactful exploits, particularly for privilege escalation or account or organization takeovers. How are you going to test for it? You're going to create two accounts, a victim and an attacker. On the victim account, you're just going to use the web app like normal, and then you're going to repeat every single request or intercept it and replace the victim's cookies with the attacker's. You can also use automated tools like Authorize to do this automatically. And that is it for IDORs. So your homework is pretty simple. Pick a target, create two accounts, and start looking for IDs. I'll see you on the next video. Bye, everyone.